So now we are going to study the page replacement algorithms in operating systems. They are basically used to do page replacement, which is a concept that when you have multiple pages in your physical main memory that you want to point to the physical memory, but you don't have space, so you choose some victim from the physical memory that is going to replace with the page you want to put into the physical memory. And there are several algorithms for that. We will study the first in, first out algorithm first. And what you're going to be given with is a set of numbers as a string. They refer to as a string, and you're going to be given these 4 frames. Like if they give you like 3 frames, number of frames, then you would have 3 boxes here. But for this question, I'm assuming the 4 frames, right? And how do this algorithm works? So we are going to study it this way. This is basically 1. It's not, the 7. So now we can start writing or we can start working with it. So what we'll do is take some color here. We'll take some reddish. So first of all, these are my frames. These are my physical memory. So how do this FIFO works? That in the start we don't have anything loaded onto the memory. So we just load the 1 to here, and this is a page fault. Okay, because the main purpose of these algorithms is to calculate page faults, right? That how many page faults do we get here, right? So now in the next step, we also don't have 2 loaded, so that's also a page fault. So we're gonna load 1 and 2, and again we don't have 3, so we're gonna load 1, 2, and 3. Now the 2 is already in my loaded memory, so we are not going to do anything with it. For the 4, we don't have 4, so I'm gonna write 1, 2, 3, 4, and that's also a page fault. When it is already in the memory, it is not going to be considered as a page fault. Next we have 5. Now 5 is going to be replaced with the recent most number in the loaded memory, so it is going to be replaced with 1. So now it becomes 5, 2, 3, 4, and because 5 is also not loaded, it's also considered a page fault. Then 3 is already in the memory, so we're not going to do anything. 4 is also in the memory. 6 is not in the memory, so now we are going to replace it with the 2. Because 5 was the first entry was already replaced, now we're going to replace it with 2. So now here comes 5, 6, 3, and 4. So now this is what? This is also a page fault. Now I think this was kind of 7. Let me confirm. 6, 7. Yeah, it was 7. So now 7 is going to be changed with 3 because we go from top to bottom. So 7 comes here and 4 comes here, and it's going to be changed. Now 2 is also not in the loaded part, so it is going to be replaced with 4. So 5, 6, 7, 2. So this is also going to be page fault. 1 is now, again, it is going to go at the top. So 1 is now going to replace with 5, 7, 2. So that's also a page fault. Now 8 is going to replace with 6, 7, 2. Page fault. 7 is already in the memory, so not a page fault. 8 is already in the memory, so not a page fault. 5 is not there, so the latest most change with this. Now we can change the 7 with 5. So 5's come here, 2, 8, and 1, and that's also a page fault. And it's important to mark them down because later we are going to calculate them. So now we have 4 here, and 4 is not the memory, so we changed the 5, 7. Now we can change 2 with 4, so now 1, 8, 5, 4, and that's also a page fault. Now 2 is not the memory, so we're going to again start at the top. 2, 8, 5, 4, so now it's also a page fault. 4 is already in the memory, 5 is already in the memory. And now we can calculate the page faults that we encountered through the point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there was 13 page faults using FIFO. And basically, what are the steps involved? That in the start there will be no processes or new addresses loaded into the memory, you're going to start loading them. If the process is already in the memory, you're not going to do anything with it. If it is not it is not it is not in the memory, you're going to replace it from top to bottom. If you have already replaced the first one, you're going to do it with the second one, the third one, and the fourth one. So this is how LIFO works. Sorry, FIFO works. LIFO was last in, first out.